We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
In today's episode, we invite two researchers and white paper co-authors from Hitachi-Imperial Centre for Decarbonization and Natural Climate Solutions. Dr. Nadine Moustafa, specializing in carbon management and decarbonization technologies, and Paola Sáenz, carbon management expert and visiting researcher at Imperial. They will discuss the briefing paper, Destination Net Zero, What is Your Best Path? Proposing different technologies, the readiness and deployability, energy and heat requirements for decarbonization, the paper's insights for policymakers, and the role of biodiversity leading to net zero.
Hi everyone, I'm Nadine. I'm a researcher at Imperial. I'm based both in the Centre of Environmental Policy and Chemical Engineering Department. And today I'm joined by one of my brilliant co-authors for the paper that we wrote in collaboration with Hitachi under our Hitachi-Imperial Centre for Decarbonization and Natural Solutions. The paper is titled Destination to Net Zero and What is Your Best Path? And I just want to start by asking Paola, what was your contribution to the paper? What do you do in the Hitachi Imperial Centre? And then I think I can go with myself after that.
Yeah, sure. Great to be here. My name is Paola Sáenz. I am a visiting researcher at Imperial College London at the Hitachi-Imperial Centre for Decarbonization and Natural Solutions. And I'm also a research associate at Sideline Climate, a platform that provides data analytics on the energy transition. I worked as a postdoc at the Hitachi-Imperial Centre for Decarbonization for about 1.5 years, a little bit more, and throughout that period, we did research that basically shaped the outcome of this briefing paper, which I think it's quite relevant to everything that we're hearing right now about the energy transition.
Yeah, and I think our research in general focused on decarbonization technologies, what are the trade-offs, like modeling the trade-offs between energy systems and carbon removal and how to integrate those different decarbonization technologies, including, obviously, CDR, which we both work on, carbon dioxide removal. And that obviously makes a big part of the paper, right? Like talking about carbon dioxide removal and how much do we need from that. And I think we'll touch upon that in a bit. But first, I wanted to ask you, so this is a net zero paper. Essentially, what do you think makes it different?
So I think one of the things that makes it different from all the things that I've seen out there is that we don't really say there's a single path to reach net zero. We provide 4 different scenario archetypes where different energy demand is projected up until 2100. That's the point where we reach net zero. There's different energy demand projected with a different mix in the grid. There's different in policy behaviors and also consumer behavior. There's also a different amount of carbon dioxide removal that we're going to need depending on the path that we follow. And another thing that I think it's different is that we don't really, we sort of rank these scenarios not from best to worst, but also from like a systems perspective, taking into account biodiversity and also, this system thinking of what you need to do in order to get there.
Yeah, and I think an extremely important message in our paper is that we're showing all these different, as you mentioned, scenario archetypes. So they're all different, but they all reach net zero, right? So we reach net zero no matter which pathway we go to. But they're quite contrasting, as you mentioned, in things like the technology mix that you will use, the land use pressures, which is inevitably correlated to biodiversity, the carbon dioxide removal, which I want to mention that regardless of the scenario we take, we see that we need carbon dioxide removal, right? It doesn't matter which scenario we do, even if we do extreme technology innovation and extreme decarbonization and lower the demand by people making more sustainable choices, for example, we still have those residual emissions that we need to remove using carbon dioxide removal technologies. But as you said, I think the fact that we need to think about this from a systems perspective, and acknowledge that, there's no one right pathway, and having this flexible approach to reaching net zero, because we need to start doing things now, and we need to note, and I think we talked about this, right? We need to have this top to bottom approach where we're looking at all these different scenarios and how they're getting to net zero. But at the same time, we also need the granular approach, bottom to top approach, looking at, what technologies do we have? What are our resources? What's our demand looking like? And then, meeting somewhere in the middle, whilst having, this flexibility and acknowledging that you can be on a pathway and you can change maybe. And having those timely measures is quite important. I think it's one of the main conclusions in our paper.
Yeah, and understanding that things are going to change. They're inevitably going to change. We don't have a crystal ball and we're not able to see the future. So corporations and nations that are preparing for their plans for net zero, they need to take this into account. They need to do that top to bottom approach of trying to understand or predict what's going to happen in the future with this many different scenarios, and what are the different pathways that they can reach net zero, but also the bottom to top approach, seeing their assets, seeing their region specific opportunities that they have for different technology deployment. And I think it's really important to highlight that in all scenarios, as you mentioned, we reach net zero, we reach the same goal, also in the same temperature goal, so we reach 1.5 degrees. But some of them have overshoot, some of them don't have overshoot. And this really depends on the policy decisions that we're going to make, on the energy demand that we're going to have, and the decisions ultimately that us as humans make.
Yeah. And I think we want to note that our paper used the transport industry as a case study. Although we do that, our paper kind of really talks about the net zero scenarios and how you can navigate that, giving insights to like policymakers and decision makers within industry as to how to basically deploy their net zero strategy or think about their net zero strategy. And although we use transport as a case study, you could use this systems thinking with any industry. But I did want to ask, generally, why do you think we used, or like, do you want to kind of give our audience an insight as to why we used transport as our case study?
Yeah, I think transport is a very interesting study. It's not only relevant to Hitachi from, an energy and transport perspective, or energy and mobility perspective, but it's also a sector that is considered one of the hardest to decarbonize. It contributes to pollution, to emissions, and there are lots of different ways that you can decarbonize transport. And it's not just a single industry. I mean, you have maritime, you have rail, you have aviation, you have road vehicles. So there is a different set of the technologies that you can apply that are different for these sectors within a sector. So there's lots of things to explore there. And as you said, for a systems perspective, we don't only take into account transport and mobility itself, or these different subsectors of maritime, transport, and road, but also how do they mix with the energy system more broadly. Because in the end, if one of your solutions is to electrify, for example, your road transport, then you need to take into account, well, how does that look from an energy perspective? What is the demand of that renewable electricity that you're going to require to decarbonize that sector? So we don't only focus specifically on transport, but we look more broadly in that sense. And this is something that you can apply to all different highly emission sectors.
Yeah, and I think I just want to highlight the fact that, for example, in our paper, we look at the different technologies that you can use to decarbonize the industry. And as you've mentioned, even those subsectors will be quite different. So whether it's electrification or hydrogen or synthetic fuels, and then the respective infrastructure for all of that will differ depending on if you're looking at aviation or freight or maritime. And so it's quite interesting to see that, you know, in any scenario, you're going to be needing a portfolio of the different decarbonization technologies, and that portfolio will differ depending on the needs of the specific sector. But yes, as you mentioned, although we use transport as a case study, you can use that thinking for any industry that you want to look at. And I think I briefly talked about this, where all the scenarios required CDR, and in this paper specifically, you were the one in charge of carbon dioxide removal, and how we looked at that. Do you want to talk about that a bit more?
Yeah, I think in the introduction we mentioned that in the end, regardless of the scenario that we choose, we're going to have some emissions that are going to be hard to abate, and that we're going to need we're going to have some residual emissions. And to achieve net zero, you're going to have some sort of carbon dioxide removal in your mix. Now, this doesn't mean at all, and I think this is something that the scientific community agrees, that we don't need all the other mitigation strategies. We need renewables, and we need to apply renewables as much as we can to the different sectors to try and decarbonize them. But in the end, you're going to end up with a 10-15% of your emissions that are going to be extremely costly to abate, and that you can abate it with the current technology mix. So that's when CDR comes in. And what we did realize is that in every scenario, regardless of the energy demand, regardless of us changing drastically our energy use and using as less as we can and as more efficient as we can, we're still going to have residual emissions, and we're still going to have a certain amount of carbon dioxide removal. Now, how does that carbon dioxide removal mix look? It's also a big question. And again, it wasn't that you need to answer from a systems perspective. So in the scenarios that we talk about, we have both engineered and nature-based solutions. Not in all of them, you can see a lot of engineered solutions like direct air capture. For example, you can see a lot of bioenergy with carbon capture and storage, and sometimes direct air capture. And this is not necessarily how it's going to be. As I said, these are all model-based scenarios derived from IAMS. So what the IPCC uses, and a lot of these models that are out there, they actually model mostly bioenergy with carbon capture and storage, so BECCS, and direct air capture. So they don't really include, for example, all these different technologies like enhanced rock weathering or biochar, and all the different CDR options that exist. But that's why we also did sort of like a technology assessment on all the different technologies that exist right now, both nature-based and engineered solutions. We looked at afforestation. At reforestation, we looked at biochar, we looked at enhanced rock weathering, we even looked at blue carbon and ocean alkalinization. And we looked at from the technology perspective, like how ready these technologies are and how deployable they are, but also from an environmental perspective, what type of co-benefits and trade-offs this technology uses, and particularly on the engineer side of things, what's the energy requirements and the heat requirements that you need for these technologies. Because in the end, engineered solutions are still quite expensive. You're looking at probably between $300 to $600 per ton of CO2. Versus
that's being very optimistic.
That's being very optimistic. Yeah, that's probably more on the BECCS side. And if you look at the DAC side, that's probably a bit higher. But in the end, you also have nature-based solutions, which are a lot cheaper, but also a lot more exposed to natural disasters, for example, or to change. So one of the main conclusions of the paper is also that they're not competitive. You're not being like, oh, should we use engineered solutions or nature-based solutions, in the end, you're going to need both. You're going to need a portfolio, and they're not competitive, they're complementary. In your net zero strategy, you should have some nature-based and some engineer-based. Again, depend on the assets and depend on the region that you're located in.
Yeah, and it's interesting because when we started this collaboration with Hitachi and us being lead researchers in our respective projects, my project focused on carbon accounting initially, which generally looked at carbon accounting for firms, looking at their different scopes, so scope 1, 2, and 3, so their indirect emissions, and how can we calculate that, how can we allocate that, how does that fit into their net zero strategies, and so on. And it was interesting because later on we started collaborating because the CDR world is, moving really, really fast. And one of the main things that came out of CDR, as you mentioned, like nature-based solutions might have a lower permanence than engineering-based solutions. One of the things we saw as we were doing this project is that it's quite important to also do the carbon accounting for carbon dioxide removal technologies. And then my project kind of involved that as well. So, and just generally the importance of, I think one of our conclusions as well is that looking at carbon accounting in general, so not just CDR or companies, but in general is quite important, kind of standardizing that, making sure we're doing it right, but also acknowledging that, we're doing it right to the best of our knowledge right now. And, as we know more, that can evolve, and being flexible with that. And I think there's this overarching theme of, this is what we were proposing based on the best of our knowledge right now, and we need to be flexible with how that will work out, in next year, the year after, and so on, especially with fields that are evolving so much, such as CDR, because you mentioned as well that, we were using the IPCC scenarios, which is the Intergovernmental Panel on Climate Change. And they majorly just include BECCS and DAC, so bioenergy with carbon capture and storage and direct air capture. We don't expect that will be the case in the next cycle. So in AR7 that comes out with IPCC, they are going to be looking at all of the different carbon dioxide removal approaches. They will also have a whole chapter on it. And so, as I mentioned, these things are evolving. And as we talked about quite a lot so far, is that we need to have plans, both top to bottom and bottom to top, and we need to be flexible as to how we're going to be deploying them as we go, like revisiting our decisions based on the knowledge that we have. And I think that also that's applicable to carbon accounting in general.
Yeah, carbon accounting is at the heart of all these things. And not only from a CDR perspective, but also, how do you get to net zero,
Yeah.
And I think also companies and governments are starting to look at this more seriously and calculate this all more seriously, hopefully. And so what are some developments that, for example, you've seen in the carbon accounting world?
So as you mentioned, it's something that people are doing a lot more now, kind of being transparent about how they're doing their carbon accounting approaches and how they're calculating their carbon emissions. It's supremely hard, as expected, to do your scope 3 calculations. So for our listeners, in case that you haven't come across this, but scope 1 and 2 are your direct emissions. So scope 1 is within your building. Scope 2 is your electricity and heat, which is relatively easy to calculate. But then scope 3 emissions are your indirect emissions. So, for example, your emissions from your suppliers, your emissions from leased assets, for example, from your distribution and so on. So those are a lot harder to calculate and get the data for.
And if I remember correctly from the work of yours that I've seen, that represents actually most of the emissions.
Yes.
So about, 70, 75%?
Yeah, 60-70% of your emissions will be, more than 2/3 basically of your emissions will be scope 3 emissions. And so we need to be very careful with those, right? Because as you mentioned, in all scenarios, we needed carbon dioxide removal. And this is assuming that we do all of our carbon accounting perfectly, right? We're probably going to get some things wrong. So the carbon dioxide removal wedge that we think we have will probably be bigger, right? But what we want to do is that we get robust, transparent carbon accounting the way we have financial accounting right now. So it's quite easy. We have all the systems, all the companies publish their finances, and we kind of want that with carbon as well.
That's the goal.
Yeah, and it really differs depending on where you are in the world, because there are different policies. Scope 3 emissions is something that people are talking more and more about. There's innovations and technologies that people are looking into. So looking at basically digitally doing your carbon accounting. So looking at things like blockchain, for example, is something that's up and coming and people are looking into when it comes to carbon accounting. So it's quite an interesting field, and I think the main outcome from everything we've seen is that Scope 3 emissions are quite hard to measure. We're working on it. There's a lot of different things at play here, and I think it goes back to the same conclusion that we've been saying this whole time. We need to do the best we can right now, and be flexible with the fact that maybe next year. We haven't done it perfectly, and so we can, recalculate our carbon emissions, which, by the way, has happened. So there are companies that, for example, that I've seen their carbon accounting calculations, and for 1 year they said, it's X, and then the next year they were like, oh, we needed to correct something because we figured something else out, and I feel like being this transparent is what we need to do, right? Just being transparent in the process, having a robust carbon accounting methodology, whether it's for companies or for CDR, is supremely important. I think a lot of people are working on that, even in the CDR world. But we'll get there, right? Like, it doesn't need to be perfect. It just needs to exist, and it needs to be updated as we go.
And I think in the carbon dioxide removal world and the carbon accounting world, there's one clear intersection there for me, which is the monitoring, reporting, and verification. You need robust carbon accounting to understand how much emissions, how much CO2 you're going to remove. And then that's going to tell you, that's going to give you a good indication of what the price of that, of those carbon dioxide removals should be. And right now we're looking at the industry of MRV as a whole. But in reality, no single company should be able to do the monitoring, the reporting, and the verification. Yeah. So we kind of need to split that into the 3 different things that they are, and understand the carbon accounting role in each of them. But that's something that, we'll wait and see how does that develop.
Yeah, and I think there's one other part that's quite important in our paper that we didn't touch upon, or we did touch upon, but we didn't explain further. Is the role of biodiversity in all of this. So both of us have a background in chemical engineering. Both of us worked on decarbonization technologies, carbon dioxide removal. And one important aspect in our paper that we talk about and really, really highlight is that it's so important to look at how the ecosystems will react to a lot of to everything we're doing. And we shouldn't have this siloed thinking of, looking at this decarbonization technology by itself and just not looking at anything else. And we've seen that, a lot of what we do can affect biodiversity a lot. And we've seen that, for example, in the land use pressures. And we really, really need to consider that. And we definitely touch upon that in the paper. I don't know if you have anything else to say about that.
No, I think that's a key outcome, and I think when companies or nations are developing these types of transition to net zero strategies, they need to consider that. And in the carbon dioxide removal section, we also touch upon trade-offs and co-benefits in terms of, for example, the nature-based solutions and how they give you so many benefits in terms of biodiversity and ecosystem services versus, for example, the engineer ones don't. But again, it's all going to depend on where you deploy these solutions and where you have the capacity to deploy them and to take care of them. But again, I think that the center was really, really focused from the beginning of, we want to have the portfolio of technologies that we're going to use, but we also want to understand what is the impact of those technologies in biodiversity and ecosystem services. So, I think, just echoing what you said, super important to not have that as a separate thing, but as a core, really, of your decarbonization strategy. And if you have your portfolio of technologies that you're going to use, understand how that is going to impact the ecosystem and the biodiversity in the region or in the zone that you're going to apply those.
Yeah. And I think maybe we can end this by me asking, and I'll think about my answer in a second, but what do you hope, so we say this is insights for decision makers and policymakers, right? This is what the paper is about. So what do you hope industry or policymakers take away from this?
I think 3 things. So first of all, you don't need to be thinking about a single or best path. There are going to be many pathways, and you need to be prepared for most of them, or at least, start preparing. That's the other thing. Start preparing now, not later. You're going to need a lot of these technologies. So start, looking at what's working now. Start investing now. Start understanding how that portfolio of technologies is going to look, and have biodiversity at this core. Understand that everything that you do is going to impact biodiversity, and you need to thoroughly assess your technologies with that at its core.
Yeah. And I think just to add to that, it's quite important that policymakers, but also industry, think that a lot of these technologies require, investment infrastructure, investment in their infrastructure, and it's not going to happen overnight. And so we need to stop thinking about things in 5-year windows, but instead, long term. Yes, 5-year windows to have this granular approach, and but we also need to start thinking about what do we need now, from now until 2100, right? And to do that, you need those long-term signals from policy, just to kind of de-risk the investment into a lot of this infrastructure. And again, a lot of this should be collaborative, like it's academia, industry, and policymakers working together in those windows, in those 5-year windows, trying to see, are we doing everything based, again, to the best of our knowledge, this is our plan so far. Let's reconvene, once we do some of these things and see what we get with that, especially as you said, we have a lot of different pathways to net zero, and so we might need to pivot some of the things we do. So it's quite important to do that, but it's really, really important to send those long-term signals, because you need to de-risk the investments into those different technologies. And the other thing I would say is that we said this a lot already, but we need those granular, sector-specific, and flexible net zero strategies. And we need to acknowledge that there is no silver bullet, right? Every single net zero plan will have a portfolio of different technologies. And we show that in our paper, right? We show that we need a portfolio of different technologies, whether it's from carbon dioxide removal, whether it's from decarbonization technologies in the transport sector, whether it's from meeting the energy demand. And so that's quite crucial. And I think I'd maybe end with that.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share, and subscribe to stay up to date with our latest content. Until next time, stay curious.